Hey, hello, this is Dave DeHilster. I know it's been a long time. We're trying to work on that, but hey, life gets in the way. You have tuned into Saturday Science Chats. Yes, you have tuned into Saturday Science Chats with the John Chappell Nash Philosophy Society and Dissident Science. And today, of course, we are going to be talking about. I made this title, he didn't, so please. I'm sure he's going to say, that's not the title, but I made it the title, Einstein's Ether. Of course, that's super intriguing because everyone knows Einstein supposedly killed ether. And we have an expert, in my opinion, a very well read and well studied and well written expert in Einstein, everything Einstein, actually everything in Einstein wrong, Roger Anderton, and he's going to be talking about today how Einstein's 1905 paper actually has ether in it. And I can believe it, but you have to find out yourself. But that's who you're going to be. We're going to be hearing from today and talking with. And of course, congratulations for everybody watching. In fact, I want to give a super congratulations to everybody. I wish I had like applause or something like that. The CNPS has reached 1,000 subscribers. So if you're on the CNPS channel right now, the YouTube channel, I don't know. You can check, maybe put in the chat, folks. If you can see a super chat there. I know in the Dissidents, I want to thank all my Dissident Science subscribers. I've got more and more jumping on the bandwagon, and I do appreciate it because you're not going to find anything like this anywhere on the internet. But I do want to congratulate you for watching. That means you are a critical thinker, and you have the mark of an educated mind and are able to entertain thought without accepting it. And thank you. Hey, Steve Bryant. Hey, it's great to see him. Got to read Steve Bryant's book. What is it? Disrupting Physics. You got to read it. If you haven't seen it, go to our YouTube channel, both on the Dissident Science and the CMPS, and check out not only his book, but him talking about a book. Super great guy. Great to see him here today. Another critic of Einstein, but he also has a better solution for it. So we don't just criticize, because everybody says it's easy to criticize, but it's hard to come up with something new. So congratulations to the CMPS channel for passing that 1,000 mark subscriber. And again, if you're watching right now, just hit the subscribe button. Even if you don't watch it, hey, hit it because it helps us. Hit the like button as well. The more likes video gets, the more they come up on the algorithms, et cetera, et cetera. So please do that. And of course, we are up to, 4,200 subscribers on Dissident Science? Yes, I'm hoping to do more. I've been really busy in my personal life, so I hope to be doing more even on that channel by my lonesome on there. And of course, we are all fighting together, so let's fight illogical mainstream and not ourselves. Yes, we can disagree on things. Hey, I'm talking to an etherist today, and I'm not an etherist, but I find it fascinating. I love the ether model just as much as I love the particle model in the sense of thinking about how it works and how it could work, because it's all, we can think about what we want. Nobody rules our heads, not yet. They can't get inside there. So we have the ability and right to think and do whatever we want when it comes to science and models. And certainly mainstream, the one thing we can all agree is mainstream science has huge problems, not small problems, huge problems. Every Big Bang, particle physics, relativity, models for gravity, models for light, magnetism, the whole thing. We've got so much to do. So let's fight for the truth and not fight each other, and support each other. Even if you don't agree, try to help each other with the models that people are working on. And of course, my dad said something like this, or I think he did, or I hallucinated he did, but we are all wrong. We are all wrong. Some ideas are just less wrong than others. And that's totally true. So this idea that I've proven, or this is proven, or Einstein's proven, it's just all baloney, because you can't prove anything. What you can do is you can have a prediction. You can support. I saw that on the Facebook page for Einstein's Facebook page, which I am a top fan. I get a little diamond for that because I make so many comments there. And the reason I do is to give people the other side. And it used to be when I made a comment like, how do you say, a not positive comment about Einstein and the worship of Einstein and all that stuff, and I give people real links, real papers, real ideas. It used to be that I got more laughing at me's than I did thumbs up. Not anymore, folks. The thumbs up are coming more and more. If you want, join the Facebook page, get out there, and there are what, almost 20 million people there. So it's seen by quite a lot of people, and it's a way to get your work out there. I say, hey, Einstein isn't right because of this reason. Go read my book, says Steve Bryant or someone else, or Roger Anderton. So again, we're all wrong. It's just that some of us are less wrong than others. And of course, the CMPS mission is to be an organization, above all, that promotes critical thinking without malice. You're not going to, this is the only organization like this on the planet. There are other organizations out there who are outside of mainstream doing great work, the Electric Universe. There's some other ones, Tesla Tech, those people. But we are the more scholarly side of the spectrum when it comes to people outside the mainstream and challenging mainstream. And we support and we publish and we promote scientific work outside the mainstream, provide a forum for open debate about modern topics in physics, cosmology, etc. And of course, to provide a forum for presenting serious papers and theories without fear of censorship. Just like today, we're going to be having Roger Anderton, which I love. I'm going to show you. He has his YouTube channel. You guys should subscribe to that as well. We've got to support each other. And of course, we have 3 websites that are doing quite well. I think we've passed 100,000 views on beyondmainstream.org. And that's an online science magazine for critical thinkers. And so if if you're saying to yourself, if you stumbled upon this live or you stumbled upon this with and the recorded version, you go, come on, mainstream's got problems. Oh, go to Beyond Mainstream and click on problems, and you will see problems in all the areas. Yes, believe it or not, the mainstream science has big problems in all areas. And of course, if you want to join our critical thinking community and say you want to join in discussions about all things physics and cosmology and even philosophy outside the mainstream, if you come on and says, I've got a new theory, people are not going to laugh at you. They're going to say, oh, what is it? Explain it to me. So it's a way to interact. And we have a very nice website. You can go to naturalphilosophy.org. And of course, we do have a Wikipedia. And that Wikipedia is wiki.naturalphilosophy.org. We have over 10,000 pages there of information. Now, we survive on our memberships and our donations. We do. We have $2,300 from our websites to our server to the software we use, like this StreamYard, to everything. And we still need more memberships, people. Please consider. We're going to get to the point where our donations aren't going to be able to hold us up, and you're going to wonder why when you go to the naturalphilosophy.org, it's down, because we've got to pay for these things. I'm even having to look to cut things if we can't get more and more people. We are, luckily. So please consider doing an annual membership, $35, $50, a donation anytime, $5, $10, $25, $50 a month. We have people in all those categories, and we do need it. So please consider that. It is vital to us. I want to thank our patrons, Nick Percival, Dr. Cynthia Whitney, Ramsey, his pen name, and of course all the annual and monthly memberships. And we need your vital support. I hate to keep saying this, but it's true. And I can't do if I were independently wealthy, who the heck cares? I just pay for it all and just smile. But that's not the case. So we do need your support. It's very important. We do have Lifetime Achievements Awards. I have been contacting those people, so you don't want to miss that. We're going to have, there's so many people who have done such great work over the years. It's time finally to get these people recognized before they're gone, unfortunately. We had just Ed Dowdy. I don't think maybe I'm thinking about talking with his son, and then maybe giving him posthumously the award. That guy should have, and that's what kind of shook me, saying we got to pay attention to that. So anyways, we're going to do some shows coming up, and if you have somebody in mind you think should get it, let us know. And of course, we are looking for hosts and guest hosts. We have always open. The idea, do you enjoy talking with people? Do you have an interest in supporting critical thinkers? We really need people who have the ability to engage, to listen, to keep things positive, and to support everybody. I do. I support people who think something I believe is incorrect, because we got to support each other. And like I said, who the heck knows who's right or wrong? So yes, you can contact me at david@naturalphilosophy.org. I just wanted to take a little time before we get in and talk with Roger and his talk. But Neil Adams, if you don't know who he was a cartoonist. He passed away just in April, the end of April. We're in the beginning of May. I just found out about it by Stephen Hurl, who is an expanding Earth guy. He's a mechanical engineer that figured out that dinosaurs can't survive in today's gravitational field, and that it had to be 1/4 the gravitational field. And Neil Adams is the reason I even heard about expanding Earth, believe it or not. He came up with some amazing videos. He is, just look him up. He is a very famous cartoonist. He was a very famous cartoonist. Here's a picture of him, I believe, speaking at Maryland, the University of Maryland. I got him to write a paper for us. He says, I'm not a scientist. I said, look, you've been talking about your pair production and the how pair production happens inside the Earth, and that makes it expand. So it's really sad that he is gone. He was 80 years old, and he was quite a cantankerous. I think he was one of the first speakers that swore like a sailor. It was like he was talking and the F words coming out and all that stuff. But he was delightful. He was really a critical thinker. He was stubborn, yeah. I mean, if you tried to talk him about other ideas about why there was a growing Earth, he didn't go for it. But again, it didn't matter. His contribution was awesome, and we're going to take a look at that. Here is his website, and you can see actually up here there is a science part, and this video here has over 2 million views. This is the expanding Earth, and it has over 2 million views. In fact, we're going to take a look at it. Haven't you seen it? Because I do want to sort of make sure people recognize him. I know he also was in conflict quite a bit with some of the expanding Earth people, especially I know Dr. James Maxwell, who in my opinion is the greatest geologist that ever lived. He's alive and kicking, doing very well, thank goodness. But when he said early on, when he tried to contact Neil Adams, there wasn't a whole lot they could do. Now his animations are fantastic. They're not exactly right according to somebody like Dr. James Maxwell. But again, it's really important. You can go to just look up Neil Adams, Neal and Adams and Growing Earth, and you'll find everything. In fact, he has lots of videos on here that he made that are free, that just don't do the Earth. He does Mars, he does Ganymede, which NASA has said is expanding. They have some weird ideas of why, but again, it's growing according to him. And just to sort of, oh, here it is. You can go to neiladams.com. And you can see his videos here. Again, this has over 2 million views. Here's the moon. He does Mars. He talks about, I think, the Great Rift on Mars and Ganymede. That's a really good one. And Ganymede and Europa. If you haven't checked them out, you can even see this Ganymede right here. You can see the plates that fit together. It's just so darn obvious. It's not funny. So the answer to the question, is the Earth the only one expanding? The answer is no. The evidence that other bodies are expanding is quite, how do you say, striking. So go to neiladams.com and take a look at his videos. But I'd like to just at least play some of this because it is what got me into it. If you've never heard of it, and I think it's just well worth watching. It's 10 minutes. I don't think I'll play the whole thing, but I'd like to play this, in homage of Neil Adams, who probably has more views on a a real dissident science, critical thinking video on YouTube than anybody else. So thanks for what you've done, Neil. Let's take a watch. Can you hear it, everybody? Nope. You can't hear it. Oh, you know why? Because I have to take it down, and then I have to actually remove it and stop screen, and then I got to add it with audio. I forgot all about that. Share your audio. Here we go. Let's try it again, and here we go. It's well worth it.
We come to the earth, which well grew to get here, the way it is now. Here is our world, our planet Earth, floating in space. We will be going backward in time, imperfectly, but done in a
Sorry, I want to get it full screen. Sorry.
very disciplined manner. Please notice there is no subduction, no rotation of tectonic plates, no twisting, no form-fitting, no altering shapes or sizes. It would be impossible for these continental plates to fit together perfectly without this being true, and yet the upper tectonic plates fit together perfectly on a much smaller planet. Yes, there's been some erosion, landslides, blah, blah, but overall this activity is insignificant. There is a kind of conspiracy of silence among certain scientists. They know, but are not telling you, that the upper tectonic plates of Earth also join in the Pacific. Not partially. They join totally. You are asked to believe that the continents swim or drift about willy-nilly, bumping and crashing as if they were on a greased skillet. This is not true. The simple truth is apparently too upsetting for too many apple carts. We're now going forward in time to show how the actual growth of the Earth took place. Imperfect as to details, but the overall is nailed. Antarctica, as you see, has become subtropical. Africa, on a smaller globe, moved way downward under the globe. In fact, for hundreds of millions of years, the bottom of Africa was the South Pole. South America's tail goes under and wraps around the bottom of Africa. Then incredibly, it joins coast with Antarctica. 65 million years ago and more, these continents were joined, and marsupials like the duck-billed platypus roamed from Australia, Antarctica, and across southern South America and up into Africa. The platypus. Dinosaurs roamed all over this world on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and its surrounding islands are the remaining home of marsupials. Do you see how broadly the Pacific is opening compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to easily visualize because it's so big. The Atlantic spread is so obvious that a child would recognize it, but they are the same. Check this map out. The Navy and others took core samples to find the ages of the sea bottom. Lo and behold, no part of the undersea was found to be much older than 70 million years old. Does that shock you? It should. It shocked the scientists. Where do they get ancient fish fossils from? From the land, like in Mississippi and Utah and France and China. Most of the undersea wasn't there 70 or 80 million years ago. The measurements of the core samples give the age of the sea floor. Newest, 10 million or so, is red. As we go back in time, we go backward in our rainbow, orange, yellow, green, blue, okay? So we bury the new sea floor back to the fault lines as dictated by color or age. 10 million years back, These are the ages of the seafloor as measured by science, and they're generally true. Earth grew. 20 million? I'm not making this information up. This map comes from the scientific community. 30 million. You can find the same map in many places on the internet. It's common knowledge. 40. The ocean bottom is from 1 year to 180 million years old. 50. 70% of it is no older than 60 million years old. 60. The upper plate, the continents, are as old as 2 billion years old and more. 70. 10 to 20 times as old as the undersea plates. The undersea plate is new and spreading at the rifts. Why does the scientific community desperately cling to and promote the idea that the ocean bottom is sliding under the continents and into a magma which is twice as dense as solid granite? A totally unsupportable and scientifically unsound idea? They have to. Or else they'd have to observe and admit that the Earth is growing. And that, viewers, is a very big deal. That would change everything in science, from the smallest particle to the whole universe. 100 years of scientific theory out the window. That's a lot to give up. It's important to remember that science and the universe should and must be easier to understand as we go back in the universe's evolution. This is an undersea map. As a kind of test for ourselves, we deemed it important to show that not only the upper plate had to fit properly together, but the undersea had to spread in a logical, reasonable pattern that we could see and understand as rational humans. Do you see those lines in the undersea which, beyond information, show direction? The direction of movement apart and away from the rifts. In fact, it's like a movement diagram, isn't it? We're moving now. Let me point out that the newer undersea near the rifts is smoother and more regular than the older land further away from the rifts. Here in the Atlantic, the rift goes right up the middle. Half of the Earth's growth has happened since the extinction of dinosaurs. This means that the Earth is accelerating in its growth. In the last 65 million years, Earth nearly doubled in size. The last redoubling took 600 million years, at least. We're continuing all the indicated undersea directions like following a blueprint. The Earth guides us. And now the land masses will come together perfectly. As we now go forward in time from 185 million years ago, please notice there is no subduction, no raising and lowering of land masses. There can't be. It's hell in the form of magma down there. Local raising and lowering, yes, but not on a massive basis. It can't happen. There's no turning, rotating of land masses. The land masses sit in their individual plates and don't move. The rifts open, that's all. For examination, I'm going to run a few vignettes of each area of Earth that you have a right to be curious about. The North Pole. Man, I love this map so much. There was a piece in the recent National Geo. It shows that the trees in Asia and North America were exactly the same trees. Well, this is why. The land was together when the trees evolved. The South Pole. The oceans have absolutely nothing to do with tectonic spreading, except that they cool the thickening mantle. Tectonic spreading, even according to the most conservative scientists, has created 2/3 of the Earth's surface in the last 200 million years. And therefore, the same must be true on all planets, including Mars. Must. And we can see the younger spreads on Mars just as on Earth. But there is, just as clearly, no subduction on Mars. It can't be both ways. You either have spreading and subduction, or you have only spreading, and you must have spreading. Or you can continue to ignore the facts and say, as the ancients said, that the Earth is unique and singular in the universe, and that we are the center, and the universe rotates around the Earth. It is now going backward in time. There.
Okay, folks, I appreciate put us up here again. I wanted to do that because Neil Adams passing is sad for all of us who really got to know Expanding Earth with his work, and that of course me led to get to know Stephen Hurl. I got to get to know all the other people in our group, including of course Dr. James Maxlow, the greatest geologist of all time. So now we're going to get to oh my gosh, how can I okay, there we go. Now we're going to get to our main topic for today. And I do appreciate everybody's patience, but I thought that was, again, when people pass by, we want to recognize them. So, but today we're going to talk about something extremely interesting, and that is relativity, Einstein's relativity, especially his 1905 paper, and what is claimed by Roger Anderton, and he wants to show you today, is that in the 1905 paper, there is hidden in there an ether. And this is extremely interesting because there's very many etherists out there and who subscribe to the idea that light is a way, the medium for light is ether, and that it also can describe other things like gravity and magnetism, that kind of thing. So it, to me, is very interesting because, as we all know, Einstein's one that's claimed to fame was to kill ether. And yet, if you really study it like Roger did, he has a different take on that. So who is Roger Anderton? Well, he is a semi-retired telecommunications engineer with an honors degree in math and physics, who went on to study physics in greater detail and found that a great deal has been removed from the standard physics education which he was taught. He is now through social network in contact with others pursuing this line of research, and of course has been doing his own YouTube channel. Here it is, and if you want to know how to get there, I make these things easy for everybody, and I would please ask everyone, again, support your fellow dissident, those people out there who are spending the time and their energy to look for truth in spite of the pressures from mainstream science. And if you don't know how to get there, well, just go to roger.naturalphilosophy.org. I made that take you right to this his page. He's got quite a lot of videos there, so I would check it out. And he's got a lot of commentary. He's even used some of my videos in his commentary, I think in a positive way. I haven't seen all of them because he's got quite a few, but you do want to do that. But please, again, go to it, click on it, subscribe to it. His channel is very important. Subscribe to all of our people's channels because it's important to me and to all of us to be able to have this out there and people to get these new ideas and things. So I think that's my last slide. Yes, it is. So I'm going to take that down. We're going to bring up the person of today, and here he is, Roger Anderton. How are you?
All right, thank you. Thank you. Okay, thanks. Thank you for allowing me to give this talk.
Oh, no. And where are you located? Tell everybody where you are.
Southampton, England.
Southampton, England. Very nice accent. Can you do an American accent? No.
And
My daughter can do all the accents from all around, including England, but I try to do it. It's just a total disaster. And there's so many of them, right? I mean, the different, the worst one though is my boss, I work with computers, right? He's from Cork, Ireland. And I have heard some of the native Corkian people talk. I can't understand three-fourths of it. It is so difficult. Is that true? Have you heard people from Cork speak?
I think there's two main Irish accents, and one of them's pretty bad to understand.
Okay, but let me ask you some questions. We're gonna your presentation. We're gonna start in about 5 minutes here. But tell me, how did you get into all of this? How did you get as a critic of Einstein?
That goes back a very long way now. I sort of was doing A-level physics at college back when I was a lot younger, about 17, and I gave up, found it too difficult, and then I had to pursue a job which was taking up a career in British telecoms after a lot of other things, and so it got trained up in all the technical things from that, and then I decided to go back and do a degree in physics and maths from Open University. So it was sort of like studying that in more detail as part-time yourself, having had a engineering, telecommunication engineering background, and sort of like, first of all, you go by what they teach you, and you say, "Oh, that's good, it's all right," and then you pass the exams and so forth. But then you think, well, maybe go on to do something like a PhD, and you start studying your topics in more detail, and you then start disagreeing with it. And I sort of like gave up the idea of doing a PhD because I was disagreeing with too much of it.
So okay, so where did you go to? You went to a college for just a regular math degree, and you didn't pursue physics because you weren't going to fit in because there's too many disagreements.
Well, I wasn't agreeing what they were teaching me at A-level physics, and so I gave up that and then went to the telecommunications and electronics thing.
And did something real for the world instead of making up
Yeah,
fictitious particles
yeah.
and
You got to do something to make money.
yes.
I thought, I didn't really think of doing theoretical physics as making money. It was just something you could do as a hobby.
Yeah,
So like
yeah.
something if you pursue that line, you would just end up as a
Well, I think
professor
you can.
teaching
Yeah, I think we can call
students.
it maybe fantasy more now, right? It's not
Yeah,
even.
yeah,
It's not even physics.
yeah.
Okay. I'm just going to make sure. Hey, Dad, are you there? Hey, there's my dad. He's going to be. I'm going to be bopping out for a little bit, but what we're going to do is Roger's going to speak about to us about his topic today. My dad's going to be. You're going to see my dad come up and be talking with Roger, and I'll be back. I have something I have to do, but. I have listened to his talk. It is extremely interesting. If you believe, if you're an etherist, this is a really, really interesting talk. So I just want to bring my dad up. He'll be coming back up in a little bit. And Roger, why don't you just tell us in a couple about a couple sentences, what are we about to see here?
Well, unfortunately, it's all arguable, and you can take Einstein's paper of 1905 on special relativity is pretty much the foundation of modern physics, uh, which we now do, as opposed to what Newton and others were doing. So it's the foundation of 20th century physics. But you read Einstein, and things are not very clear, and then he sort of like he gives a description. Well, it doesn't give a very good description of things, and he doesn't really explain how that then connects into the mathematics.
Right,
So
right,
when he says something like the ether is superfluous, well, what does that mean in the
right,
mathematics?
right,
And he
right,
doesn't tell you. He doesn't tell you. What does that mean? So
right.
there's just so many don't
Okay,
knows.
okay.
And okay,
Okay, so what we're going to do is we're going to start this off,
yeah.
and thank you so much for presenting this, and I'll get this started. And everyone, listen here. This is what we came for.
This talk is entitled Aether in Einstein's 1905 special relativity paper. First of all, it's all arguable, as per usual when talking about physics. This talk is based on what has come out from arguing with others. We go back to the usual translation of Einstein's 1905 paper on special relativity. It was entitled On the Electrodynamics of Moving Bodies, and this is the article here, published in 1905. So I'm not going into issues such as it might be a bad translation, and the article says the introduction of a luminescence ether will prove to be superfluous, inasmuch as the view here to be developed will not require an absolutely stationary space provided with special properties, nor assign a velocity vector to a point of the empty space in which electromagnetic processes take place. It's not really clear what that's supposed to mean, but it's usually interpreted as meaning there is no ether, or at least there's no ether in the context of special relativity. What would be good is if Einstein explicitly stated what the maths for ether was as contrasted to maths without ether, but unfortunately he doesn't do that. We're trying to make sense of Einstein's paper on special relativity. There arises lots of things to argue about because he leaves things unclear. The maths that I want to deal with from Einstein's paper is highlighted here, and you've got the equations are t subscript b minus t subscript a equals r subscript ab divided by c minus v, and an associated equation. But first I want to deal with what is said before that equation. Einstein is considering the length of a rigid rod and says all these things here. I don't want to read it out too much, but basically he has a rigid rod and he's considering light going from one end of the rod to the other. And he then goes on to say the length to be discovered by the operation B we will call the length of the moving rod in the stationary system. And he goes on to assume something, and what he assumes that the length ... and eventually he's going to drop that assumption. When he drops that assumption, what Einstein seems to be doing is constructing a math equation of length of the rod, L, and that's lowercase l, which looks like a 1, as the length of the rod, r subscript ab, multiplied by a relativistic factor. And that is what leads us to the maths I want to deal with. Einstein says all this. We might imagine further that at each clock there is a moving observer, and that these observers apply to both clocks the criterion established in section 1 for the synchronization of two clocks. And he goes on then to give these equations. So when Einstein is dealing with these equations, he must be getting them from Newtonian physics, because they don't have the relativistic factor that is to be added later. Now, with Newtonian physics, there is two versions of Newtonian physics. there is Newton's particle or corpuscular theory of light and Huygens wave theory of light. So here it is, it's Newton versus Huygens, and there's a great deal written on this, and Einstein, as per usual, is not going to give sufficient detail in how he's thinking about these things in his special relativity paper of 1905. In fact, Einstein is going to totally omit mentioning whether he's using Newton's particle theory of light or Huygens wave theory of light. It's just that Einstein says ether is superfluous, so that would make one think he isn't using the wave theory. But now let's work out the maths for these two theories. Well, it's going to get a bit complicated. First, deal with the particle-like situation. So here we have a rod with endpoints A and B. Light leaves endpoint A to go to endpoint B, and the rod is moving with speed v in the same direction as the light, which is moving with speed c. So the light is the yellow coloured arrow, and the rod is moving with this in the same direction as the light. But when the light gets to endpoint B, the rod has moved from where it originally was at the time that the light left point A. So we need to start labelling a few positions. So the rod has endpoints A and B, and the light leaves the endpoint A when it's at position A subscript O, and during that the endpoint B is at position B subscript O. Light reaches endpoint B when the rod has moved to position B subscript 1. So the light has moved from A subscript O to B subscript 1. Something similar occurs on the return journey, and the return journey is this: the light bounces back from position B subscript 1 and gets reflected back to endpoint A. Light on the return journey reaches endpoint A when it's at position A subscript 2. So need to write the equations for all of this. So I have to do the Newtonian calculation for the light particle, and so let us say A is originally at the position A subscript O, and B is originally at the position B subscript O. So light goes to the right direction from A subscript O, and B will move from B subscript O to a new position B subscript 1 further to the right. Thus light travels from A subscript O to B subscript 1, and the time for this light for the light to do that is T subscript B minus T subscript A, i.e. light leaves A subscript O at time T subscript A and reaches B subscript 1 at time T subscript B. So time from A subscript O to B subscript 1 is T subscript B minus T subscript A. and so we can form the distance from that for what the light has travelled. If B had stayed at B subscript O, then the distance would be from A subscript O to B subscript O, and that would have given the equation there of just C times the time interval of T subscript B minus T subscript A. But light has moved a further distance, which is from B subscript O to B subscript 1, and that is the velocity v times the time interval. So we can form the equation for the length of the rod R subscript AB. And as a reminder, Einstein never explained any of this in his special relativity paper. The return journey is from the times T subscript B to T A subscript dash, and you note the use of the dash. So the time interval is T subscript A dash minus T subscript B, and from that we get the C minus V all times the time interval. The rod length is then R subscript AB, and that is C plus V times the time interval T subscript B minus T subscript A. And from the return journey you also get the distance, and that is C minus V all times T subscript A dash minus T subscript B. Next you need to do a Newtonian calculation for light wave, and now with that we have an ether frame. Waves have a medium, light is a wave, so must have a medium which is called ether. The Michelson-Morley experiment was trying to measure light speed relative to an ether frame, and was treating light as a wave as per Huygens theory. So instead of a particle you have a wave, and I've shown the difference here. You've got what looks like a dot moving along, or you've got a wiggly line moving along. So for the wave we need an ether frame. Let's denote that as from position A subscript O, i.e. light is moving relative to that. Light moves from position A subscript O to position B subscript 1, and light moves with speed c, and it takes time t subscript b minus t subscript a, and the distance travelled is a subscript o to position b subscript 1, and that is c all times the time interval t subscript b minus t subscript a. And now the rod length is r subscript ab, which is position a subscript o to b subscript o. So you have to subtract v all times t subscript b minus t subscript a from the c all times t subscript b minus t subscript a, and that will then give you the length of the rod r subscript ab. Similarly, you can do it for the return journey, and it gives that equation for the rod length. So there's two ways of doing the calculation. You can do the rod length without ether, and it gives those two equations as in case I, or you can do the rod length with ether, and it gives those equations in the case of I I. Now you should take note that the letters in both these cases are referring to different things, so you shouldn't mix these two sets of equations. And we need to contrast that with what Einstein gave. So back to Einstein, he gave these equations. We can rearrange these equations in the way shown, where rod length r subscript AB equals c minus v, all times the time interval t subscript b minus t subscript a. And you also get the equation for the rod from the return journey, and that's the rod length with the ether. So that's the case I instead of the case I from earlier. Einstein's math is based on light wave, which is Huygens theory, and not on the particle light theory. So Einstein does a calculation to get rod length based on using ether. He seems to say there's no ether, but he uses ether anyway in his maths. And there's at least two possible ways to look at this. First way is Einstein is mistaken when he says no ether, or interpreted as saying no ether, and really his theory has ether. Second way, Einstein is bad at maths, and really he has no ether, as he seems to claim, so his maths needs amending. Now, reminder of Lorentz's theory. Lorentz has the same maths as special relativity, but Lorentz is keeping the ether. In order to keep ether fitting with the Michelson-Morley experiment, he was adding what has later become called the relativistic factor, and the way that it's often portrayed is Lorentz, who together and independent of an Irish physicist by the name of Fitzgerald, suggested the reason light waves travelling with or against the ether wind in the Michelson-Morley setup got to the receiver at the same time as those travelling an equal distance across it was that the whole experiment apparatus mysteriously shrunk in the line of its movement by just the right amount to compensate for the ether wind effect. So basically Lorentz is trying to keep ether in his theory, but he's adding length contraction to keep the ether. So based on a straightforward look at Einstein's Special Relativity 1905 paper, Einstein has an ether frame, the same as Lorentz's theory, just Einstein seemingly confused things with his words when apparently he was discarding the ether, and he wasn't using the relativity postulate despite stating it. When you've got using a preferred frame, you're not treating all the frames the same. So bringing in an ether frame, you're not using the relativity postulate. But all this course is arguable because can keep making different amendments to Einstein to try to make sense of what he's saying. As some people argue that Einstein made mistakes in his maths and mistakes in what he was saying. Thus it becomes impossible to agree what is really meant by his 1905 paper on special relativity. That weakness is one of its greatest strengths, because it allows people to believe whatever they prefer to believe from it. So my final protest is modern physics is based on the work of Einstein, but the maths that Einstein originally presented does not make sense. The focus on the maths not making sense seems mostly ignored by the mainstream, and they just carry on regardless. But the Dissidents seem to do the same in not wanting to focus on the maths. What it results in is the maths of special relativity gets adjusted. It's then not precisely defined theory. Can't then properly test a theory if it gets adjusted ad hoc. There is no point coming up with alternative theories to the mainstream when the maths that existing theory is based upon is imprecise. You need to sort out the mess in the existing maths before being able to offer alternatives. Else you just keep going around in circles. Thank you at the end.
I'm sorry. He was supposed to click on stuff. He didn't do that. So I'm going to mute some people. For some reason, we got the. Oh, I know what it is. I'm going to remove this. And I'm going to remove this.
Okay.
I'm so sorry about that. I got somebody. There we go.
Yes.
Oh, I know. It's on my phone. Sorry about that. There we go. Okay, Roger, thank you so much for that presentation. So, what was it that led you to come up with this idea that in the math itself there was, you know, how do you say, evidence that there was an ether?
Well, of course, I've been going for a long time by what Einstein has been saying, and by what he says, it gets interpreted. He's does away with the ether frame. So I think, well, he's not using a wave theory, just from what he's saying. But then it's a question of how does he get that in his maths? And so I've argued with a lot of other people, and one person I pointed out to me the difference between the wave theory and the particle theory, and really Einstein is still using the maths of the wave theory. And when you're using the wave theory, well, that means you've implied that you're using the ether frame, in which case you're doing exactly the same thing as what Lorentz is doing. You're sort of like, you're trying to work from an ether theory or wave theory, in other words, and you're trying to make it work with the Michelson-Morley experiment. And he's adding or introducing the relativistic factor to try to save the ether theory. And well, Einstein doesn't say he's doing that, but effectively he's doing the same thing. It's just that he's saying he's.
So why is it? Was it Einstein himself that said ether wasn't needed, or were people around him saying that?
Well, in his paper, he says it's superfluous, which gets interpreted as meaning he's saying you don't need it. And so people latched onto that as, well, that gets rid of all the problems of when you're talking about the ether theory, because the Michelson-Morley experiment was creating problems if you wanted to believe in the ether theory. And so people just latched onto what he said as meaning there's no ether, so you can just discard that, and therefore you've got an easy explanation to the Michelson-Morley experiment. But that was from people who weren't really properly looking into the maths and seeing that it's really still got it there. So it's all a mess.
It was absolutely a mess.
Everything is a mess.
Yeah, you know what I look at? I say myself, looking at the Big Bang or relativity or particle physics, it's like this giant Gordian knot. Yeah. And if you try to undo it, to try to explain the logic of how it's illogical, you go absolutely nuts. You feel like you're going around and around and around room trying to find a corner.
You go around in circles. Yeah.
So what was, other than just saying that ether was superfluous, I guess it wouldn't be until general relativity that he would try to have any kind of explanation afterwards, because it seems like 1905 just says, oh, it's superfluous, but then he doesn't say, well, what is it? He had his photoelectric effect, then all of a sudden it's a photon. But at that point, he's not explaining the wave properties. He doesn't have something like my father, which was, okay, you can have waves of particles. There you go. You got it. They didn't have anything.
Yeah, exactly. So, he doesn't explain how his mathematics connects to what he's saying. You've got a disconnect. So, and you also got no references from him saying what he's working from. So you can't check what he's working from. So you kind of like, he's not giving you enough information. It's all like everything is wrong. The whole paper is unacceptable. It's not.
Oh yeah, absolutely.
But we've built on it. The physics community have built on this paper, and it's completely unacceptable. You cannot make sense of it, because you've got to say, well, you've got to amend it in some way, but then people want to amend it in different ways, because you say, well, Einstein's no good at math, so he's saying there's a relativity principle, therefore what he means is the math should be altered to be conformed to the relativity principle. Or somebody could look at it and say, well, he's got the ether in the maths, so therefore it's a mistake to say it's a relativity theory. So you've got too many different directions you can go from his paper in trying to make sense of it. And it just gets worse for general relativity, because with general relativity, when they try to read that and make sense of that, as he sort of like admits in a famous talk he gave in 1920, I think it was Leiden, when he talks about the ether, he seems to be admitting that the ether exists in a certain form in his general relativity. So he's discarding it in 1905 and then bringing it back in 1920. And then it's sort of like, well, he's not explaining how he got rid of the ether in 1905. He's not explaining how he's bringing it back. He's not giving you the maths to make sense of what he's doing. So it's completely, this is just written by somebody who doesn't know what they're doing.
Yeah, I mean, here's somebody. There is no preferred frame. That is the whole point. Well, yeah. Now
on the relativity principle.
Yes, yes,
Yes.
and so if you look at it's funny because it's talked about so much. When I was at a school where our company was donating some money to a robotics department, well, this school has a lot of money. And so they invited Bill Nye, the science guy. And so he pulls out his phone, and I'm like in the front row, and he goes, this, the GPS on this phone would not be correct if it were not for, and he said literally the words, special relativity and general relativity. Now, if he even knew mainstream's own explanation of special relativity and general relativity, you would know that special relativity isn't it's not a what do you have going on there? A dog?
So my wife just turned up.
Oh,
she's been singing.
But I mean, one of the things is the whole thing was general relativity sort of saved special relativity, right? And so, but you get people like Bill Nye the Science Guy saying both are important, and if it wasn't for them, you can't get the GPS on your phone, which is a lie because they don't use it at all.
Yeah, but you've got the maths, the mathematics. I get confused between the Americans saying math and English.
Right.
Maths.
Sure.
You got the mathematics, and they just bodge it. They just bodge it to fit the experiment, and then you say, well, that's Einstein's right. But you got Einstein saying things like relativity principle, which means no preferred frame. But then when you look at the math, wait a minute, he's got it in there. He's still got it in the math. So what is he hasn't explained the words he's using with the mathematics he's using. It's sort of like the two things are not connected.
There's just it's just I mean, it's like it's like trying to if you're imagining that special relativity and even general relativity are like somewhere, a place on Earth. It have to be a swamp or quicksand because there's no place to stand. You cannot find one solid piece of ground to stand on. And one of the things that was really interesting, I got all into this was because I met Dr. Karazani, and he looked at the maths of special relativity, and he noticed that the velocities that were put together and squared were not the same velocities. And so if you're, it's one thing, what happened is what you had in special relativity and what Karazani found was you had a person dealing strictly in math, strictly. That's it. They weren't looking at what it meant because the moment they take a V here and a V here and then square it, they're not That'd be like saying, okay, I'm traveling in my car. You're on a train. You're going 100 kilometers mile per hour. I'm going 20 kilometers per hour. We're going to
Yeah,
put them together, and we're in their V's, and we're going to square it.
yeah.
It's
It's just a nightmare. Everything.
yeah,
You've got relativistic velocities, and you've got a relativistic velocity addition, and then you've got classical velocity addition, and they're not the same thing. So what Einstein means by speed or velocity in his papers can't mean the same thing as what you would use in classical physics of Newton. So you're using the same symbols. You're using the same symbol V for two totally different things, and that's just a bodge. It's just all bodged all the way through. There's nothing. There's nothing other than just bodging.
yeah,
It's
absolutely.
like if Einstein was a plumber, he'd come to your house and just make a bodge job. Everything would be a
You
mess.
come into the kitchen, and the pipes would be going up
It's all like,
into the
what? All these pipes sticking out from everything, and it might work for a while. Then you have to come and take things back up again. But it's just a total mess.
Yeah,
It's not a professional job.
yeah, yeah.
You want a decent job, and and that's the foundations of modern physics. It's just a bodge job. It's
Yeah.
nothing you can.
Well, it's turned into science poetry as much as we talk about, right?
Yeah.
Because if you listen to these people speak, if you listen to David so-and-so, who won the Nobel Prize here in the United States for his work in particle physics, and supposedly he's making it more simpler, and you see the interview, he's being interviewed by Alexander Unziger. It's just poetry. And the moment you take any of the logic that that person said and then throw it back at him and say, wait a minute, they just go, they live in this Harry Potterish poetry. It's almost like particle physics is like poetry. You know how you go to those poetry places, like some place, it's like a bar, but it's poetry, and they're all sitting there, and the guy, they say it's sort of like a Monty Python skit, where the only thing stupider than pissing in the dark is not pissing in the dark. I mean, they just make these things up, and everybody goes ho ho ho, and everyone talks about it, and they just flowery. So let's put up some of these comments here that I do see. This is Kenneth Morey says, Albert Einstein used Lorentz contraction of a moving rod because a scientist could not get published in 1905 if they did not accept the Lorentz contraction. Is that something that makes sense, or?
Well, the Lorentz transformations were around before Einstein.
Right, of course.
You had Poincaré and Lorentz were the main ones working on that. So if you were going to use that sort of thing, you should be citing it. But Einstein didn't. He didn't cite any papers from what he was working from. So you've got a disconnect between what Einstein's saying with what people previously were saying. So,
I would love to get into Einstein's head and ask him, why didn't you reference anything? What was the reason?
yeah.
I mean, I just would like to know. I mean, yeah.
But people take that he didn't cite those papers as he was being original. He was sort of like an original thinker, and he was
Right.
thinking it all through without having to be influenced by what other people said. But it's sort of like that's all very well. You originally think it, but you might as well then connect it then to what other people have said, but he never did. It's sort of like it stands out from everybody else. It's sort of like, well, how is it connected to what has already been done?
Yeah.
So like there's a disconnect.
Yeah. I mean,
with these sort of like big name physicists who do look at Einstein, they come to their own opinion as to what they think Einstein means. So they think they're clever and say, "Oh, I understand what he means." And if other people disagree with what they're saying, well, they just don't understand relativity.
yeah. It's like this.
You can't. People can read Einstein and come to different interpretations of what Einstein means. And if you don't go along with the person who thinks himself super genius, their interpretation, he's just going to say, you don't understand it.
Yeah, that's one of the
Yeah,
things. That's one of the things I've said. I
yeah,
made a meme about it.
yeah.
It's not what I made. I made this meme, and the meme says, is my sort of conclusion. One of my conclusions is that it's not the universe that's complicated and paradoxical. It's
Hmm.
our theories and our
Yeah,
models.
yeah,
And the other thing, what happens is they use this to say, oh, you don't understand this, then
yeah,
you need to come to our school, you need
yeah,
to learn it, and then once you learn it and can repeat it and you go to their
yeah,
tests and you can regurgitate what they
yeah,
say, it
yeah,
still makes no sense,
yeah,
yet they throw that on you. So what they do is the paradoxical problems that are real problems with the theory are thrown back at the general public that they don't understand it because they're not smart enough. But the
yeah.
problem is it's the theory's flawed.
When I was doing relativity, when they were teaching it to me, I was just going by what they taught me. It's sort of like, oh yeah, that sort of like makes sense. It's just when I thought I'd study it in more detail for a PhD, which I gave up on doing. It's sort of like, well, the literature on what's being said doesn't agree with what I've been taught. So you've got a disconnect there. And you sort of like what they're teaching you, they've tried to make amendments to what's really there. And so when you see that, you say, well, it's just you've got no proper formation of anything. You've got some teachers changing their views on things, teaching you different things. It's sort of like one of the famous ones is about relativistic mass. Uh, I've done a video on, and Richard Feynman says relativistic mass is the foundation of relativity. You understand that, you understand the theory. But then there's another person who comes from NASA, I think it is, Don Lincoln, and he's saying, "Oh, there's no relativistic mass; it doesn't exist." So they revised the theory. So like what's been taught for decades and decades is there's relativistic mass, and then somebody else comes along later and says, "No, there isn't," and they want to teach you there isn't. So they revise it. They revise relativity. So they it's sort of like, what? How can you revise a theory? You've changed the theory.
Yeah, well, one of the things in my movie, for those who haven't
Yeah,
seen it, EinsteinWrong.com, go check it out. You can watch
yeah,
it. In that, I have a Dr.
yeah.
Kelsey, I think his name is, but he was an experimentalist at Stanford Linear Accelerator. He gets
Hmm.
up in front of the camera and says, "We do not observe mass increase." And he said, we have to unteach special relativity to our grad students.
Yeah,
And the moment I called him a theoretical physicist, you just thought I had called
yeah,
his mom a bad name.
yeah.
He says, "Don't you ever accuse me of being a." He said, "There's nothing theoretical about physics. It's a real thing."
The problem with that though is to many students they teach relativity as having relativistic mass, and you go to that scientist and you try to unteach them that, they would still claim that it's relativity theory without the relativistic mass. So,
Oh, but
so
that but
they revise the theory and they still pretend it's the same theory as per what Einstein was saying, but it's
yeah.
not. And they just keep revising it.
Yeah, and what you touched upon is what this person, Super Principia
Yeah,
Mathematica, which who says, no, but wait. He says, but they do see energy increase. No, they don't. And what they do, and he's not going to listen, but I'm going to say to you, Super Principia Mathematica, you need to study Dr. Karazani, and he's right. What happens is they don't see mass increase because it's not they don't have evidence for it. But what they do is in the end game, when they calculate the energies of the collisions, they are using relativistic kinematic equations. And what that has in it is the special superpower of special relativity is that when things are faster, energy gets higher. So they're not measuring higher energy. They're using equations with the special relativity already in it. If you read Karazani's paper called Nucleus-Nucleus Collision, he uses the autodynamic equations which have no relativity. They are Newtonian. And he can describe all the nucleus-nucleus collisions without relativistic kinematics, without the need of the neutrino, which is invented, and all of these other things. So when people come up with this argument that Super Principia says, but they do see energy increase, no, they don't. They are using equations that will give them energy increase. They don't measure it. And that's the problem. That's the problem. They use one word that the Super Principia Mathematica talks and says the words they say, but they are not truly measuring it. They are using equations in the end game. So they have something coming along, they have something hit it, they gut out their math, right? They start calculating, and what do they pull out? They don't pull out autodynamic equations, which is the corrected special relativity equations that make them Newtonian, and they're no more magical energy, which you can use, which Karazani did. And then when you use his equations, it all balances. You don't need fictitious neutrinos, for instance. So the problem is that they do not see it, they calculate it, and in that calculation, they're using special relativity already. So that's the problem there. But they're not going to listen. They won't listen. You know, I'm telling this to Super Principia. He's not going to listen. He's going to say, yes, they do. So that's one of the problems.
When they do experiments, they make assumptions which they build their mathematics upon. And so if the mathematics doesn't quite fit to the data, they just start doing bodgies. That seems to be their standard way of doing it. You bodge the mathematics to fit the experiment, and you claim then the experiment still works.
See, yeah, I mean, what he's saying is, I tell them the way they do it. They use those relativistic kinematic equations. That's why they say that they use relativistic kinematic equations. It doesn't mean that they are matching what they see. They don't just see it and then, you know, because the empirical way, right? The way you do experimentation, right, is you smash things together, then you try to write equations for them. But what they do is they use equations that already exist for the things they're doing. It already has special relativity in it, and that's why they say it's true. But he was not going to listen to it. He's just going to say it's not true.
Same way of doing things when they used to believe in the geocentric theory with Aristotle. What they believed was that these planets moved in perfect circles around the Earth. And when they did the observations and it didn't, they just added epicycles. So you just bodge the mass, and you just keep bodging the mass. You keep adding a bit more onto the mass. You still believe it's perfect circles, but you just added a bit more on. So the theory is patched up. It's just a bodge in the maths.
Yeah.
The same method they use all the time. We're supposed to have moved on in our thinking, but the same sort of thinking we used then, we're still using now.
Yeah, and they've got a lot of outs. Neutrino is the best out that had. The neutrino came from, Karazani showed this, neutrino came from them looking at decay cases and saying, oh, if you apply special relativity to this, you're going to have more energy than there. It's funny, before special relativity, the decay cases, the energy in the system and the decay and the electrons and everything coming out balanced perfectly.
Yeah.
There was no need for special relativity, but Pauli came along and says, look, folks, you guys got to have, if you believe in special relativity, you've got electrons going at 0.86 the speed of light. That means you're going to have more energy there. And so what do? They invent a chargeless, massless particle to pull that energy away. And then it gets in everybody's consciousness is when Karazani shows this was invented because special relativity, Karazani shows special relativity wrong mathematically and conceptually. He then puts new equations that don't need the neutrino and are Newtonian. Everybody all of a sudden says, oh no, that's not why the neutrino was invented. The neutrino we detected that. And if you go to Wiktionary, and you look at neutrino, they have a part of the photo of a particle, and they say, oh, this is a muon or something like that, that is evidence It's an indirect evidence, and they say they can't even point to it because they don't have evidence of it. You only have indirect evidence. All of these things, they're standing up. People, even in the dissident world, they'll just sit there and, oh, there's a neutrino, there's a neutrino. And I said, guys, there isn't. And you call it something else. Quit calling it, people get that into their vocabulary. The neutrino then becomes part of it. When it's shown wrong and shown why it was wrong, no one listens. It's still around. Even people in the dissonant world hold on to it. People in the special relativity world hold on to it. They say, oh, of course we measure it at the end because look at here's the energy at the end. It doesn't equal Newtonian. Of course it isn't. They use special relativity kinematic equations. They call them relativistic kinematic equations. Yet, once they apply that math, they then imbue upon the world that because we're using that, then we have to have extra energy. And oh, by the way, this neutrino comes out, which you can't detect directly. Oh, that it's a part of their game that they have, and people just buy it hook, line, and sinker.
Well, unfortunately, when you do this sort of thing, you sort of like, oh, you look at the equations of special relativity and they don't quite work, and then you postulate another particle, and that makes the equations balance out, or that's then taken as a prediction. And from taking the prediction, they then start saying, oh, we've tested this in an experiment and we've shown that must be right. And so then you start awarding awards for it. So you end up dishing out Nobel Prizes to people. So you're building upon that all the time. So it's a building process, and sort of like you don't accept you've made a mistake. All you do is make another add-on, another ad hoc add-on, and then they say that's a prediction, and I'll wait now for my money for being proven right.
Yeah, I mean, Alexander Unterger said it really well. He says, particle physics is a bunch of arbitrary packages with arbitrary attributes, and they keep building upon them, and then they filter them out. So what they do is, you invent something that's just completely invented. You then say, these are the signals. Of course, the signals look like noise, and most of the time it is noise, but you pretend that's what you look for. Then you filter those out, and then you go to the next thing, and then even though it's noise, you call this spike the Higgs boson, and then everybody, gets their Nobel Prizes. And this is a question I have answered, and Karazani answered this over and over and over and over. Kev Khan, I'm going to say this again. This is ad nauseum. Why do they bury neutrino detectors underground? Why do they put them in caves? The answer is for getting them not to detect false hits. They have to shield them. As they have shielded them over time, they've had less and less neutrino hits. Guess what, folks? They are not detecting neutrinos. They're detecting something. It isn't a neutrino. That is the answer. And if you don't believe that, then ask a neutrino scientist why they have shields. What is their answer? To shield false hits. It's just, they don't listen. They won't listen because they want to hold on to, you know what they want? They built up this fantasy world, Roger, that they've built on. Okay, wait a minute, I'm a dissident, and Aether is this neutrino, and neutrino we can't detect, so that must be the one that Aether must be made of because they can't really find it. So that's it. I've seen people in our group say neutrinos are gravitons. I've seen neutrinos are the Aether. And yet we know by Karazani's work they don't exist, and why not? And you don't need them in the end game yet, and that they sealed these detectors from false hits. So yes, they are detecting something. They're false hits. That's what they're detecting. So, but they don't listen. They don't listen. It's in their head. This, like you said, they're constructing these models, right, in their head. And it's all poetry, and I've got this, and the neutrino's part of it. So, Dave, no, I'm not. Close your ears, close your eyes, and I'm not going to listen to what you're saying. It's like, it doesn't matter, because 100 years from now, when people do study it and see Karazani's work and see that he's right, it doesn't matter. They're all working on epicycles, right?
Yeah.
How many people today are working in what we would consider, you and I would consider to be the epicycles of modern physics, right?
Yeah.
Things that will disappear 100 years from now. Everybody who's clinging on to it. Does that make sense to you? Or
I'm a bit more fairer because the the epicycle work theory does work. If if you prepare to keep dodging,
you're right. Yeah, I've
if
seen
you
it.
keep dodging and you keep adding more and more
Yeah,
epicycles,
yeah.
it does actually conform to observations. And so,
That's
so
really sad.
so when modern physics people do the same, they got their theory, they got their mathematics, doesn't quite work, and so they're going to bodge it and bodge it and bodge it and bodge it. It does conform to observations because they want to bodge it enough so that it does fit.
Yeah,
It's
yeah,
just they don't want to then consider the alternative,
yeah,
and they're
yeah,
tied into if they make a bodge that actually works
yeah,
or makes it better, then
yeah,
they get money. They get rewarded. It's sort of like carrots and sticks. They get their carrot, their big funding. If they can make a bodge to the existing
yeah,
model,
yeah,
then they get funding, they get rewarded by a big Nobel Prize or something.
yeah.
So you get rewarded for that adding epicycles.
Yeah, no, you're right, and I honestly think the epicycle work was way better than
Yeah,
what they're doing today, because
yeah,
the difference with epicycles and what the they're doing today is that the epicycles were still on solid ground because they had real paths going through the sky of real objects, and so they had something. If you look at the particle physics, who knows what's really going on there? Because it's not like we all agree that they're even quarks. That's an idea, that's a theory, but we're not even necessarily the epicycles they're building are more in the line of building on top of something that's not solid ground. That's I think one of the big differences too. I agree with Richard Jess on this. In fact, I think my friend Amnon Myers, he's a colleague of mine in computer science. He and I are work together in computer science. He said to me this phrase. He says the perfect neutrino shield, meaning to shield out, there'll be no detections of neutrinos. Meaning, if you finally shield the neutrino detector almost perfectly, you're not going to get any signals at all. So that's one of the. It says I heard one of the techs at a neutrino detection experiment claiming the perfect neutrino detector will detect 0 neutrinos. Yep, I mean that is so how bizarre. So, oh, here's a question for you. Do you have any evidence of these bodges?
Well, I think when they've been teaching for a long time that there's relativistic mass, and then
Yeah,
suddenly you've got a person saying there isn't relativistic mass, that's an example of a bit of a bodge.
yeah, absolutely. In fact,
Um,
that's one of the things I think what's happening is when so many people have been questioning it, you get people like in my film saying, "Hey, folks, we don't see mass increase." Then they have to step back, right? And so
yeah,
they step back, and so yeah, they step back from it, but they still keep the rest. That's
yeah,
what you were saying too, right? If you
yeah.
say, "Okay, there is a mass increase," well then, but there's time dilation. You can't say those two things together. Is that right? Right?
All very confusing the way they bodge things.
Right, because if you don't have mass increase, you don't have length
Yeah,
contraction, you don't have time dilation. They're all part of the same package. You
well, they
can't
try to move things around a bit, don't they?
a little bit. Yeah. So let's see. Let me put this on others. Super Mathematics says, in Rogers' theory, what is the logical rationale that the ether is contained in Einstein's 1905 paper? Well, did he watch, or I guess maybe say it in a more, you know, go ahead.
What I did, I contrasted uh, light as a particle, as in Newton's theory, versus Huygens' theory, where light is a wave.
Mhm.
And when you got a wave theory, you would sort of like use a preferred frame, which is called an ether frame. And so I
Mhm.
showed the maths for that, and the two things do look different, but Einstein didn't go into explanation as to what was thinking about these things when he's saying what seems to be this ether doesn't exist. It's sort of like he's not giving you the maths for what he means by an ether theory, and he's not telling you what he means by a theory without the ether. He's not contrasting those two type of theories. So he's just leaving it vague. And so this is what Einstein does. He doesn't give you sufficient information to check on what things properly. So that vagueness from Einstein makes the theory, what he's saying, totally unacceptable, really, for a foundation for modern physics.
Yeah, I mean, you'd think that if he said these things or he postulated something, he would do at least the least you can do. For instance, when Newton came up with his equation for describing bodies in a gravitational field, he was very clear. He says, "Don't ever accuse me of ever knowing what the force of gravity is." But you never heard Einstein come up and say the same thing about general relativity. He says, "Don't ever accuse me of knowing what space-time is." He never said that. He just like the same way he never said, like you said, give any type of. He didn't even say, "Look, here's special relativity. I have a mathematical equations and I have some postulates. You can believe them or not, but that's what they're based on. And oh, by the way, I don't have any physical explanation for any of this." I think, and that's one of the things that I think that makes so many people turned off the physics when they get their first physics 101 class and they say, as you get close to the speed of light, mass increases, and you get that question, "Teacher, what happens? Is it like bugs on a windshield where, I'm going faster and faster, and so I'm accumulating by accretion more mass? What's that?" Oh, and the professor will inevitably say, "That's the law of the universe. We have proof for that," which is a lie. Yeah. And then, you get back to it. But Einstein never was humble like Newton in saying to the world, "I do not know. I have an equation for something, but I don't know what space-time is. I don't know what the physicality of why mass increase would happen or length contraction." And so he doesn't seem to have that humbleness the same way. He didn't even say that. He didn't even say, "I don't know," let alone say what it could be, right?
I've looked at Einstein in a great deal of detail, and in his physics, he needs to give a lot more explanation. It's sort of like if you're writing down some equations, you need to explicitly say when you're using the principal relativity and contrast that to when you're not using the principal relativity, and sort of those sort of steps. And sort of he doesn't explicitly state what he's doing from his assumptions. So he's left everything vague, and you say, well, as you get older, hopefully he would have expanded upon that and explained himself in better detail, but he didn't. He seemed to be diverted onto politics. He was dealing with political issues. He got nominated at one time to become president of Israel, which he declined. Right. But he was into political activism. He was campaigning against atomic bombs and lots of issues. He got diverted away from physics. So he didn't really think that physics is vitally important thing to do. He thought of his political activism was more important. And hence he's left his, whereas he should have really just done physics and explained things better. He didn't. He just left it. And that just been left a mess by him in physics.
Right. No, it is. It is. And he really, I mean, I did get to interview a friend of his. It was in 2005. He died a little later. He was pretty old. He was 87, 88, or 89. His name was Jack Rosenthal, I believe is his name. He was an electrical engineer at Princeton at the time Einstein was there. And he had put together this gift. Oppenheimer, for his Einstein's 70th birthday, wanted to give Einstein an FM receiver because Einstein liked music. And so it turned out that, again, don't quote me on the name. I'm pretty sure it's Jack Rosenthal or something like that. He was there as an electrical engineer, and he was building and playing around with FM. There was one station in New York, so they could get it from Princeton. And so it turns out that what they did is the assistant for Einstein, who was living alone at the time, and he had an assistant there, was letting this Jack in to install an antenna, because on the day of his birthday, Oppenheimer came with the FM receiver in tow with Jack behind him, and it turns out that he had already installed the antenna, because he didn't want to go up there, hook it up, and then you couldn't hear anything, because then you got to do an antenna, and that took some hours to do. So he had already pre-installed the antenna. And it turns out that what happened while this is a pretty funny story, actually. While Oppenheimer was on the front porch giving homage to Einstein, which he didn't like. It was very clear. In fact, Jack said a lot of the physicists there didn't like him because no one could understand his fame. That the other physicists who were doing what I would call real work and real physics were trying to figure out why this guy with all these crazy ideas that some of them that actually didn't agree with was so popular, but they had to pay homage. So as Oppenheimer goes up there and is making his speech on his birthday, Jack was going around Einstein and up the stairs into the room there, and he was told then, of course, he was going to hook up his FM receiver. And so the FM receiver was putting together in the middle of Oppenheimer having to kowtow to Einstein's fame, right? Einstein turns his back, leaves Oppenheimer on the porch, jawing away, goes up the stairs and looks at and just stares at Jack and had his pipe on, and he goes, "You've been here before." And Jack says, "Yes," and because he had seen the antenna. And then he turned it on, and they became really good friends. But it turned out, when I listened to Jack Rosenthal's stories and about Einstein, Jack went to Einstein's house every 2 months with he and his wife for dinner. And they just talk about everything. They talked about the bomb. They talked about how Einstein really regretted that this is the weird part, that he somehow felt responsible for the bomb because of E=mc², which we all know has nothing to do with the atomic bomb. But he was feeling bad, and then Jack Rosenthal, who was on a ship going to Japan for the invasion, turned around because the bomb stopped the war, all those kinds of things. But he would talk about Einstein was just absolutely worshipped by people who didn't even like him. And I think that fame part of it made him into this mythological character. And so he would go to lectures. John would say he would go to lectures, and people hated it when he went to his lectures. So if Roger, was giving a lecture at Princeton in physics, if Einstein walks in, watch out, because if he likes you, he'll chuckle or nod his head, you're in great. But if he laughs and sort of, you're dead. He had that. There was so much mystique around this man that he was like a god, and people didn't like it. They didn't see justification for it, and yet that's what happened, and that has continued today. One of the interesting things is, if you call people up, my mom during the film called people up, you can't find people who specialize in relativity. You said something over and over again, and you've said it over and over, and that is, relativity is considered the base, the how do you say, the foundation of modern physics, right?
Yeah.
You cannot find a person who specializes only in relativity. If this is the basis for all of physics, why is it that you cannot find a single person at a university who is considered to be, yes, that's our relativity expert? My mom called places up. The only person that was doing that was Kip Thorne from Caltech.
I don't know so much about that. It's sort of like if you've done all the basic MS masters and degrees in relativity and that, and then done a PhD, you would probably be applying relativity to cosmology or black holes and such. So you would be doing relativity, but as a specialized subject into something else. I mean, I have talked to people who've done who are experts in relativity, and they're applying it to things.
Oh no, that's true. I'm talking about a university, and
Yeah,
you have a person in they look you look them up on the website or whatever, and they have listed relativity is their main thing. Now,
yeah,
people who try to apply it and all that, those exist, but not people who. If it is foundational, you would have people that would be working on it, and you can't find that. And of
I think,
course, it's like GPS. They
yeah.
don't use it. They don't use it. They say they do. People in this chat are completely saying that they do.
I've been to Oxford University where they've given talks, and there is I think the only expert on relativity and GPS, and he gave a talk, and what he was doing, he was analysing the data they collected from GPS, and he was saying that it conformed to relativity. And he was, I think, the only expert who specialised in that.
And here, let me
So,
tell you, let me tell you why that doesn't
yeah,
work. Is number one, they're not allowed to get the equations that the companies use because those are proprietary. They're worth trillions of dollars in the end. And so
but
what they do is, but what, let me just explain. What they're doing is they're explaining how they think it works, not
yeah,
how it works.
I think he was the only person who specialised in that subject, and he was looking at the data from GPS,
Right.
and his expert opinion was it conformed to relativity, and that's what was being cited by all the other people. So
Right. And right.
if you're an expert in relativity, you've got a specialist subject in
Right.
in a part
Right.
of relativity.
Right.
So
Right.
in this point had the relativity GPS, and so you only got one person probably in the whole world who does that, and he's just looking at the data which the engineers are collecting and giving to him to analyze. He's not actually using relativity
Yes.
to
Well,
uh,
they are theoretically doing a theoretical explanation, and when you look at somebody like Ron Hatch, you know Ron Hatch works, right?
yeah,
Ron Hatch. Ron
yeah,
Hatch had over 30 patents in it. He says that GPS shows the flaws in relativity. So you
yeah,
have people like Kevin Kahn. Again, what they do is they repeat these things over and over. And like you said, you found one person, right? I can't. My mom called 50 universities. We couldn't find one. Now it
mhm,
doesn't mean they don't exist. You're talking about somebody who does. But
mhm,
the question is if you were to get a Ron Hatch together with this guy, most likely, and I asked Ron about that. He says what they do is they make their interpretation of how they think it works. They don't have the equations because those are proprietary and always will be. You're not going to get Navcom to give their equations and their calculations for GPS to the world so they can check it if it uses special relativity or general relativity for that matter. They're not going to do it. So what the specialists do is look at data and they
yeah,
make their interpretations of it. The actual calculations of the timings between the satellite, the stations on the ground, and in between satellites is what Ron Hatch did, and that showed that it didn't that relativity is not only needed, but that if you looked at it, it actually shows the flaws in relativity because if they used relativity, it wouldn't work. And
I
so,
think, yeah, from a theoretical physics point of view, they're not looking at it from an engineering point of view. So they're looking at it as the theory, and they're saying the theory matches the data. And so they're not looking at it, say, the way an engineer would try to do it. So it's sort of like it's two different ways of looking at things. You got
yeah, I
I
mean, you
got to
can come
make
up with, yeah,
yeah. GPS engineers interested in making it work, and theoretical physicist is interested in does the data collected fit my theory, and
but
so
see,
you
right,
disconnect.
right, right.
Yeah,
Right. It doesn't
so,
mean though that even if what's happening is when you look at what Ron Hatch was saying is
yeah,
that the actual calculations, that the actual things they're doing engineering wise show that GPS shows the flaws in relativity. It doesn't support it. So and when he reported that, he got a lot of silence. When he would
Yeah.
give papers about that, he got a lot of silence. And the reason is because the GPS companies do not want to go out on public and say Einstein's wrong. It's a PR nightmare. It's a PR. It's a public relations nightmare. I mean, can you imagine Navcom coming out and says, "Yeah, special relativity doesn't work. We can't use it in GPS. We have different calculations." So,
But I think they can still bodge it. That's what they do. They bodge it, and it does work. That's one of my points. You got
what you mean but who's bodging what? Is the engineers?
You can bodge the data to fit.
Oh, yeah. Yes,
when you got a theory, you just say, "Oh, if you look at the data and it doesn't quite fit the theory, you're then saying there's an extra effect going on, and so you add that as a few extra terms in your math, and you say, yeah, now it fits the data, now fits the theory, and so you can keep bodging it as the same way you do epicycles. You can just keep saying, yeah, it fits.
Yeah.
It's a bodge job.
Yeah, no, it is. It is, it's pretty interesting to me how the industry is so afraid that people are so afraid of saying Einstein's wrong. In fact, when I came out with my movie, this is what they said: Dave, you can't say Einstein's wrong. They're just going to all laugh at you. You got to change the title to something like "Goodbye Einstein, Hello Karazani." If you're looking at like relativistic equations, Karazani has a very good Newtonian alternative and a reason why you can use them, and he uses them all over the place in very different places. It's just calculations, right? But you can't say it. We had two grad students who wanted to do Karazani's experiment to show special relativity incorrect, and the grad students both had the same reaction. And they're pretty prestigious grad school universities. These grad students, when they went back to Karazani, said, "This is what happened. I went in and I said, it gave them the experiment, told them what the implications were, and both of them had the same story. The grad student was told to shut the door, and the teacher asked, 'Do you want a career in physics?' And the grad student says, 'Of course I do.' He says, 'Then don't do this experiment.'" That's not science. That's not science. I mean, you should be, if I were a physics teacher and someone came up and says, "I have an experiment to show special relativity wrong," loud and clearly, I'd go for it. You could win a Nobel Prize for that. But you don't think you can't, it doesn't happen.
With a teacher, I think there's pressure to stick to teaching certain things, so you haven't really got the latitude to suddenly teach something different. I think.
Oh yeah, I know you can't. But that you're just passing the problem on, right? I mean, universities should be the place where you can question. Should be the place where you can do that. But they're not. I know you're saying no, but I said they should be, right?
It should be. Oh yeah.
Yeah.
You got to set things which you want to teach the students, and you don't want the as the people who own the education establishment, they don't want the teacher or lecturer to deviate and to teach something completely different to.
Oh yeah. In fact,
they want things standardized.
Yeah, in fact, it was a guy who is he is a member of our group of CMPS, right? His name is Louis Sauerbone, and he's an engineering teacher actually, and he was teaching a course where people were writing about something like Big Bang or relativity or some particle physics, and he required them to look at both sides. He actually said, you need to, in your report, say what is the support of the Big Bang and what's not a support of the Big Bang. He was doing that for a number of years. And then when I called him up one day, he's in Brazil, said, "Hey, I want to find out how you're doing this because this is extraordinary and this is the way you should teach people," right? And he says, "I can't do that anymore." And I said, "What happened?" He said, "Well, a third of the students loved that exercise. A third of the students didn't care, and they just did it because they had to do it and go on and get their grade. Then another third were starting to go to my superiors at the university and saying I'm teaching blasphemy." And so that's where the problem goes. You cannot challenge Einstein at a university, and that's ridiculous.
When I've checked at these educators, say Oxford, it's sort of like I'm paid to teach relativity. When they're teaching relativity, I'm paid to teach relativity. I'm not paid to teach the alternative theories. So you've got a standard where they're going to tell you what is belief in relativity, and not going to tell you that other theories can do similar things. They're just going to miss that out. It's just a vast amount of things which they're not going to tell you. They're just going to stick to a certain thing. They haven't. What they're teaching is something which you'll be examined on. If you suddenly start wandering away from that, then you're going on to things which you not be examined on, which is not good for the students and not good for the faculty if they're going to start failing the students. You can't. They've got standard questions they're going to ask the student, and they've got they've already been taught the standard answers, like relativity works. You're going to lose marks if you suddenly taught them that what other theories work as well.
Yeah. I mean,
not the answer that they're wanting when they're in the exam.
Yeah.
So this education system is rigid on we're teaching you this. This is what you're going to be.
Well, there is one thing I would say that you're right about certain things, and it's not true with other things. Yeah. It's true with physics. It's true with cosmology. It's not true in software engineering. In software engineering, you can come up. They want you to disrupt stuff. They want you to do that. That's considered to be noble. Yeah. Why isn't it considered to be noble to disrupt physics? Just like Stephen, can't remember his name. He's here today. Stephen Bryant. Yeah. He's disrupting physics. Yeah. I want to make one more statement here. Harry Ricker, who's watching, I love talking with Harry. He's an electrical engineering guy. I think I like those guys. But he's saying, well, of course, GPS does support general relativity. Yes and no. What happens is atomic clocks are affected by gravity. Everything that's made out of atoms are affected by gravity. So yes, when you put a clock up, you have a clock running on sea level here on Earth, you put it up in space, it runs at a different speed because it's gravity. So to say that supports general relativity, no, it supports that gravity affects clocks. It doesn't support or unsupport general relativity, because general relativity is a theory that supposedly explains gravity. In my opinion, doesn't explain. It's just a mathematical equation, no different than doesn't give any physicality, no different than Newton's. It's just a different set. So I want to say that. But anyways, I think obviously we spawned lots of talk here. And I really enjoyed this. I really do want to bring you back because relativity is such an interesting topic. I've always admired your work, and I do want to let everybody know again, please go to Roger's YouTube channel, watch more of what he's doing. He has a lot of videos going on. I don't even know how many videos. I couldn't get to the end. I kept scrolling down more and more. So you have quite a number of them. And for those interested in relativity, very astute observations. I want to congratulate you for your work. And I do believe you're absolutely right that in the mathematics of relativity, he's talking about frames, right? Einstein's talking about frames. And when you talk about frames, you are talking about some type of system. And ether is a frame kind of related system, right? I mean, it's basically there is something here, and if it's moving or not moving, relative or not, that in itself. So I thank you very much. Again, if you haven't seen, if you come in the middle, please go back. There's 20 minutes of his presentation. So thank you so much, Roger. Did you want to say anything before heading out?
Okay, thank you. Cheers. One of my ideas would be to show the older videos from sort of John.
Yeah, no, I think so, and discuss them. I think that would be great because a lot of
and discuss those.
Yeah, I think that would be good. So what I'd like you to do, why don't you go ahead and choose some of those? Because a lot of times people don't have the time. This is a way we can just bring it to them. They know they have these 2 hours on whatever time they are and where they're in the world, and we can talk about that. So
there's lots of problems in relativity. It's sort of like just built all on top of each other. There's so many false claims, and you've got all these dissidents in past talks pointing out all these different false claims that are made, which
Yeah.
is very interesting.
Right. Okay.
Okay.
Well, thank you so much, Roger, and congratulations on your work again. I really admire it, and we'll see you again for sure. Okay.
Thank you. Cheers.
Okay. Take care. Cheers. All right, folks. That was great, and I apologize for the middle there. We had a little bit of a hiccup there. We did have somebody to fill in, but unfortunately, it didn't happen. But I do want to thank everybody. I know there's a lot of chatter going on in the comments. I do appreciate all of them. Everybody has as their ideas, but we do listen to them and we discuss them. If you think the neutrino exists, that's great. I don't. I think the evidence is clear, but we can be together and discuss things, and that's really, really important. And for everybody to keep track, and also to listen. I do listen to people who have a different opinion than mine as well. Like I said, I listen to etherists all the time. I don't think there's an ether, but that's my opinion only. And we all should just keep our eyes and ears open and try to understand what each person's doing. One of the things I found is even if you do not believe in an ether, or you don't believe in that light is a particle, whatever you want to say, but you should try to at least listen to people who have a different model, who have a different way of thinking, because that's where your mind's going to be opening up. So thank you so much again. And hey, let's head on out. Hey, like I say, I'm Dave D. Hilster, your critical. I don't say that. I say stay critical, stay thinking. I'm Dave D. Hilster. I am your science therapist trying to get you to the promised land of becoming a critical thinker. Get it right, Dave. Ciao for now.